Chapter 3, Properties of Pure Substances. Okay, class, today we're going to have a fun chat about something really interesting, pure substances and how they behave when we heat them or cool them. So, imagine you have a glass of water. It looks simple, right? But inside, there's a whole magical world of how it behaves when we change its temperature or pressure. Scientists call it a pure substance when it's made of the same type of thing all through, like water is always H2O, whether it's ice, liquid, or steam. Even air, if it's mixed evenly, can be called a pure substance. But if you mix oil and water, it's not pure anymore because they separate. Now, let's imagine ice cubes in your drink. That's a solid. When it melts, it turns into liquid. And when you boil it, it turns into steam, which is gas. These are what we call phases: solid, liquid, and gas. They're like costumes that the water wears, changing based on how much energy you give or take away. In solids, the molecules are like kids standing still in a tight circle, just shivering. In liquids, they start moving around, bumping into each other, but staying close. In gas, they're like kids running wildly in a big playground, all far apart from each other. So what happens when we heat water in a closed pot? At first, the water warms up, and we call it compressed liquid because it's not ready to boil yet. When it gets to exactly 100 degrees Celsius at normal air pressure, it gets ready to change to steam, and we call it saturated liquid. Keep adding heat, and you see bubbles. Some of it becomes steam, and some is still liquid, so it's a liquid-vapor mixture. When all the liquid changes to steam, it becomes saturated vapor. If we keep heating, it becomes superheated vapor, which is just really hot steam that's not ready to become liquid again. An interesting thing is the boiling point changes with pressure. Like in the mountains, where the pressure is low, water boils at less than 100 degrees Celsius. But in a pressure cooker, where the pressure is high, it boils at more than 100 degrees Celsius. That's why food cooks faster in a pressure cooker. We also use charts to show this magic world. There's something called the TV diagram that shows how temperature and volume change, and the PV diagram shows pressure and volume. The coolest point on these diagrams is called the critical point, where liquid and gas become the same thing. There's also something called the triple point, where solid, liquid, and gas can all exist together like a fun party. For water, it's at 0.01 degrees Celsius and very low pressure. Below this pressure, water can skip the liquid stage and go straight from ice to vapor, like dry ice does. Next, we have property tables that work like cheat sheets. Instead of calculating everything, we just look up values. For water, we have tables showing temperatures, pressures, volumes, and energy amounts. When we have a mixture of liquid and vapor, we use something called quality, which is just how much of it is vapor. Quality of 0 means all liquid, quality of 1 means all vapor. We also use a special property called enthalpy, which is just energy plus a bit extra for when things expand. This helps engineers like us calculate energy changes, especially in power plants and refrigerators. To sum up, pure substances follow simple but beautiful rules. They change their phase when you give or take away heat. They have magical points like saturation, critical and triple points. And thanks to property tables, we can figure out exactly how much energy we need to make these changes happen. Everything becomes easier and clearer when we look at the world through these diagrams and tables. That's all for today, and next time we'll have even more fun applying these ideas to real machines.